Good morning students, I am Sasikala, Assistant Professor in KPR. So today we see about what's the meaning of context-free language, how we can create a good context-free strings by using Chomsky Normal Form. So the context-free language is only accepted by push-down automata. The push-down automata designed using stack and the input tape. So it can store the full length of the input strings. It can read the input strings from left to right, and it can have a history their previous input. So the inputs are very important here. The push-down automata only accept the context-free language. That is, everyone know that. In theory of computation, each model accepts different kinds of language. So one important language is context-free language that is accepted by push-down automata. So the important grammar, the important language, context-free grammar, still have different kinds of protection rules. There. So by using the Chomsky normal form, just we give the structure for the strings and the production rules. So we give the basic structure for the context-free grammars and its strings. So by using Chomsky normal form, so simplify your context-free grammar and its production rules. So there you have only two rules. You can create or you can write a production rule with two non-terminals, or only one terminal. So in this slide, I create A tends to B, C, or A tends to A. So on the right side, I have two non-terminal in the name of B, C, and A. There is only one non-terminal. So this is all the very important rules. So when you create a context-free grammar, just follow this Chomsky normal form. Okay. So Chomsky normal form, just to simplify your context-free grammar. So give the standard structure for your grammar, because this context-free grammar is used to create a set of accepted strings, a set of valid strings are created. So when you follow the Chomsky normal form, you can validate the given strings are accepted by your model or not. So this is a simple application of how create the grammar by using Chomsky normal form, in short form CNF. Okay, this CNF only applied in context-free grammar. So by using this CNF, you can create a valid production rules. So through this production rules, you can create a valid strings. These strings are accepted by your push-down automata. So now everyone clear in introduction. Next one, everyone know that what is non-terminals and terminal symbols. So non-terminals, everyone know that A and B. For example, I give the value for A and B. So send email. So send email is my value, or any other value I can give to my non-terminal A and B. Okay, for example, int A equal to 10. So A is my non-terminal, the value 10 is my terminal. So from this example, non-terminal have multiple values. Okay, that is name of terminal. So here I write the three rules that is followed in Chomsky normal form. All the rules are must followed during developing a context-free production rules. Okay, the first rule is a non-terminal generating a terminal. Okay, a non-terminal, a single non-terminal X generating only one terminal, small x or AB. A non-terminal generating two non-terminals, x tends to y, z, both are non-terminal. Also, the starting symbol only generate the epsilon. There is no epsilon productions allowed in your production rules, but applied in only one place in your starting symbol. Okay, these are the basic three rules. So each non-terminal can generate one terminal or two non-terminal symbol. At the same time, epsilon transition is not allowed, epsilon production rules not allowed, but you can apply it only for starting symbol S. Okay, shall we go to one example? Before going to your example sum, just I recall 3 or 4 key points before how to convert the normal context free grammar into CNF format. So any context free grammar can be converted. Any kind of context free grammar can be converted into equivalent grammar. Okay, in Chomsky normal form you can convert it, but it's never affect their production rules. Also, a single context free grammar can be converted into different kind of CNF format. Okay, the production rules can be converted into different kinds of CNF format by using your 3 production rules. Also, when the context free grammar must follow the CNF product and release the same accepted language. So that is created by your context free grammar. The last one, if my string length is n, triple n, okay, then the CNF derivation requires at most 2n minus 1 derivation step. Okay, so when we show one example, you can understand these points. The last one, any context free grammar that does not generate epsilon. Okay, the last already we discussed it. Any context free grammar does not generate epsilon. Okay, in CNF. These are the key points. So now I here explain what are the steps needed to convert the context free grammar into CNF. So we follow the 3 rules, step 1, step 2, step 3. We must follow the same order, never change the order. So eliminate the epsilon production that is not allowed in your CNF. Okay. Next, eliminate unit production. So unit production is nothing but it make a looping. So you break the looping concept. Eliminate the unit productions. Then remove the useless symbols. These are the 3 steps. So never just to follow this order. Eliminate the epsilon productions, eliminate the unit productions, and remove the useless symbols. So example, A tends to ASB and A tends to AAS, A or epsilon, B tends to SBS, ABB. So this is all your production rules of the context free grammar. Here listen, the S tends to ASB, there is a 3 non-terminals is repeated here. At the same time, epsilon production is also repeated here. So the production rules never follow the CNF rules. So now we go to convert this production rule with the CNF rules. Okay. So the first symbol, the starting symbol S. Okay, the starting symbol S never repeated on right side. But here the S is repeated on your right hand side. So I create one new starting symbol S0. So S0 is my starting symbol. Now I create S0 tends to S. So only one non-terminal is allowed here. Okay, so this is the first rule number 1 we created. Remaining 3 lines are same. Never we change it. So S0 tends to S. The S0 never repeated on your right side. So I create the S0 as a starting symbol. Next, for your step 1 is, what's your step 1? Eliminate epsilon productions. So after creating the starting symbol, we want to remove the S tends to epsilon is a null production. So we should remove. So listen, here I mark the letters in red letter. So that is the output when you remove the S tends to epsilon. Okay, just apply the rules in your grammar. For example, in third line, A tends to small a, capital A, S. Here you apply A tends to epsilon. The remaining output is A, S is right here. You can listen. So the red color marked output is A tends to epsilon's output. At the same time, S tends to ASB. Apply A equal to epsilon, then remaining letter SB is repeated. So the same concept applied for p tends to epsilon. The same rules again we repeated up to remove the epsilon symbol. So the first step completed. Next one, remove the unit production. For the example, for the production rules B tends to A, we want to substitute the A value directly in B production rules. So directly I substitute B tends to, what's the A value? AS or A. Directly I substitute the value here instead of the capital letter A. Okay, the same concept again repeated for S tends to S naught tends to S. So we remove this unit production rules. So the output is right here. Last one, in the production rules, A tends to AS or AS, B tends to SBS or AS. Okay, here, so ABs are terminals. Okay, ABs are terminals. Now we have only one terminals. On the right side, we must have only one non-terminals. Then we want to remove the X tends to A and Y tends to B. Okay, so now listen the letters. Here I create the two production rule, X tends to A, Y tends to B. So here I substitute A tends to X and S. Okay, both A and A, both combinations of non-terminals and terminals removed here. So the non-terminals X substituted for the small letter A, at the same for Y for the terminal B substituted here. Next, S naught tends to ASB have more than two non-terminals. Okay, we have permit only two non-terminals. So here I create one more production rule, is P tends to AS and substitute the P value in my starting symbol S naught. So this is are the final production rules we created after replacing the S tends to ASB, A tends to XAS, B tends to SY, S and XAS, because these four grammars have three non-terminals. We permit only two non-terminals only. So I create one more production rules in the name of Q equal to AS, R tends to XA, P tends to XY, U tends to XA, and substitute the values in the grammar S, A and B. So this is the final output. We create this production rules that must follow the Chomsky normal form. Okay, you can apply different kinds of grammar. For the same sum, you can create different kinds of production rules. Okay, so all the rules must deliver same kind of accepted string model. There is no changes in the output. So the output is your accepted strings. These collections of strings are known as language. So the context-free languages are delivered by using your context-free grammar. When we follow the Chomsky normal form, you can create a good production rules. Thank you, students.